Hi, I'm Dick Collins. When we learn to fly, we're exposed to a lot of facts in the process of being trained for the written and flight test. What we don't get is a lot of depth on why things are important or how they relate to the management of the risks of flight. In this series of AirFacts tapes, we're going to take a look at that, beginning on this tape with what we do before flying. Most pilots also drive cars. The main pre-drive effort is finding the car keys and perhaps glancing at the gas gauge before driving away. Flying is more challenging than that, and our considerations relate mainly to three things: the pilot, the airplane, and the plan for the flight. Let's look at these things in ways that aren't spelled out elsewhere. The pilot is a complex part of the equation because the person who wants badly to make the trip is the same person who decides that the pilot is up to the trip. How does the pilot feel? We all know the rules about drugs and alcohol, and I think everyone has read the labels on over-the-counter medicine that caution about drowsiness. All this is well and good, and all the rules and cautions should be heeded. The main requirement is that the pilot feels well and alert enough to devote his entire attention to the flight. If anything, a cold, a hangover, a life event such as a marital spat is weighing heavily on the mind of the pilot, then he may not be a very good pilot. Simply put, if you're going to fly along thinking about something other than flying, maybe you shouldn't be flying. Another pre-flight item for the pilot is in matching proficiency and currency to the flight at hand. If a pilot is worried that the weather or other conditions might be a little over his head, the outcome might not be good. If the pilot has limited experience in the airplane to be flown, the same is true. None of this is to suggest that only perfect humans with perfect brains should go flying. Nobody is 100% all the time. It's just up to us to weigh any compromises and be satisfied that they won't cause a problem. If the answer to a question is only, "I think I can make it," then it's a bad deal. Certainly, if a pilot flies into weather with uncertainty in his mind, he's not likely to perform as well as when the weather is thoroughly understood as well as acceptable. I fly one airplane, mine, a lot, and a lot of different airplanes a little. For my airplane, I know when to calculate weight and balance before flying. Still, I keep the weight guidelines with my checklist and know that no balance question arises unless the airplane is loaded from rear to front with the heaviest stuff at the rear. For all other airplanes, I calculate. There are few airplanes around that you can fill with fuel, put a fanny in each seat, and load the baggage to the placarded limit without exceeding the maximum weight and possibly the balance. In fact, the certification requirements specify only that at maximum weight the airplane carry a 170-pound person in each seat, full oil, and enough fuel to operate for 1 hour at maximum continuous power. Alternately, the airplane will meet the standards if it will carry the required crew and full fuel and oil. That's the standard airplane too, and we all do like lots of optional equipment. Why is weight and balance so important? The maximum weight of an airplane might be set where it is because of structural strength, performance, or engine cooling considerations, among other things. Exceed the maximum weight and you become an experimental test pilot and remain one until the weight is within limits. The center of gravity limits are related mainly to the stability of the aircraft and the pitch axis. The farther forward the CG, the more stable the airplane becomes, meaning it takes greater stick force or turbulence to displace the airplane in pitch. The forward CG limit is often set by a requirement to have the elevator power to land on the main wheels first in a tricycle. The aft limit may be set by a number of things. On singles, it is often the requirement to recover from a one-turn spin in one additional turn. It takes strong stability to be able to do that. The result of trying to fly with the CG after the limit can be nothing short of disastrous. For example, the airplane can be so unstable that the application of full forward elevator might not keep the nose of the airplane from rising so far that the stalling angle of attack is exceeded, and the airplane stalls, out of control, in other words. There are a lot of things to learn in the pre-flight process for a less familiar airplane. One in particular is the autopilot. All the limitations and characteristics of the autopilot are covered in a flight manual supplement. A pilot who flies without reading and heeding the words there can have serious problems. For example, with virtually all autopilots that control pitch, if you try to override the autopilot, the electric trim system will trim against you. Pull back on the wheel with the autopilot on and it will eventually roll in full nose-down trim. Also, some autopilots have automatic disconnect parameters, and these should be understood. If, for example, you let the autopilot fly into a bad patch of turbulence, it might disengage and beep as if to say, "Hey Ace, you directed the airplane into this stuff, now you fly it out." Also, if you wear a headset, as we all should, you want to know whether the autopilot disconnect tone sounds in the audio system or just in the speaker where you might not hear it if wearing a headset. Finally, it is important to know all the means of taking power away from an autopilot. They can go berserk, and there are a number of ways to disconnect, usually including a disconnect or interrupt switch on the control wheel, plus a switch on the autopilot itself, a circuit breaker, and the avionics master switch. The pilot's operating handbook is an important thing to have for all airplanes flown, and if you're a renter pilot, it's a good idea to develop a library of POHs for everything you fly. Make sure the collection also includes manuals for all the avionics systems likely to be encountered. What about the general condition of the airplane? The ideal arrangement is when it's your airplane, nobody else flies it, and it lives in a T-hangar. You put it up after a flight and it rests untouched until you pull it back out. Many pilots can't have it that good, which emphasizes the need for thorough pre-flight inspections and knowledge that the airplane is covered by a good plan for routine maintenance, including the resolution of all squawks. I like to keep a list on my airplane of when things are due, things like prop overhauls and any recurring service letter items. This jogs my mind on maintenance. If you're a renter pilot, it's more difficult to keep up with this, and the best thing is to be satisfied that the club or FBO has a good maintenance program. One important maintenance item. After an airplane has had serious maintenance, give it a test top before starting out on a trip. This is no reflection on the shop. It is recognition that airplanes are complicated, and if much has been done to them, it should be checked out. Even be wary after simple maintenance, like an oil change. I have had 2 filters that leaked badly after an oil change, and both were caught quickly and without further ado on a short flight. On the 210 that I fly now, a few minutes after takeoff following an oil change, I extend the landing gear and have a look. Any oil leak results in a great collection of oil on the gear legs and the main gear tires. The fuel plan for a flight is important. Fuel exhaustion is a leading cause of engine failures, and that's a real tragedy because there is never an excuse for running out of fuel. It is simply a not right thing to do. How to make a plan? I like to do it this way. Set aside 1 hour of fuel at normal cruise as a reserve. Subtract this from the total carried. Then subtract an allowance for taxi and additional fuel used during takeoff and climb. I allow 1/2 gallon per cylinder for normally aspirated airplanes and 1 gallon per cylinder for turbocharged airplanes. Here's how this works. Consider a turbocharged 6-cylinder airplane with a 90-gallon fuel capacity and a fuel burn of 17 gallons per hour. 17 would be subtracted for the reserve and 6 for the taxi, takeoff, and climb. That's 23, leaving a total of 67 gallons to use for the trip. That's 3.94 hours. A little more pre-flight exercise helps. We know that wind forecasts are approximate. How do we keep from being bumfuzzled by a bad wind forecast? Simple. Say the trip distance is 500 miles. Divide that by the flying time available, 3.94 hours, and the required ground speed is 126.9 knots. If it falls below that, the plan changes to one with a stop to buy fuel. One final thing on fuel. Look in the tanks to make sure they're full, even in a high-wing airplane. Just being a little short might take a big bite out of a calculated fuel reserve. Next comes a look at the airfield requirements. Guidelines are useful. For the light airplanes that I have owned, I have used the number 3500. If an airport is less than 3,500 feet long, or the density altitude is above 3,500 feet, I calculate takeoff and climb performance before flying. Conservative, but it can help avoid misadventures. When using the takeoff and climb data in pilots' operating handbooks, remember that the numbers there are superlatives, test pilots flying new airplanes in ideal conditions. We thus need to add a margin for safety. When my 3,500-foot guideline sends me to the books, I consider the minimum acceptable runway length to be 2.2 times the ground roll distance shown for takeoff performance in the POH. To get an equally conservative figure for up and over a 50-foot obstacle, I double the book figure. That isn't as restrictive as it sounds. For example, my 210 is a ground pounder on a maximum weight takeoff. At an elevation of 5,315 feet, the book shows a 1,870-foot ground roll at plus 20 C. That means my minimum runway length for that condition is 4,114 feet. Fly it at that weight, elevation, and temperature, which is what you're watching now, and you wouldn't settle for any less runway. For minimum landing runway length, I use 160% of the total distance shown to land and stop from 50 feet. This comes to 2,432 feet at maximum landing weight, which is 200 pounds less than maximum takeoff weight, so it isn't restrictive either. Incidentally, takeoff planning for multi-engine airplanes is more complex and is covered in a tape dedicated to that subject. When going on a trip, a complete survey of the route, distances, terrain, and options along the way is helpful. IFR, we need to consider any standard instrument departure procedures or other departure procedures to begin, and standard terminal arrival routes at the end of the flight. VFR, we need to make a plan to deal with regulated airspace. Classes B and C are especially important if we happen to be flying through more congested areas. It is a lot easier to make a plan and look up the frequencies that will be required before takeoff than it is to try to figure out how to make peace with airspace requirements as the airplane is bouncing around and traffic is out there begging to be looked for. The terrain and en route airport survey is important to both VFR and IFR flights because both loom large as a consideration if something dictates a change in plan or if something on the airplane malfunctions. I'll give you an example. Consider a trip from Hagerstown, Maryland to Asheville, North Carolina. If the airplane is slant R, meaning RNAV or an approved LORAN or GPS, the most expeditious route is Victor 377 to the Kessel Vortac, direct to the Holston Mountain Vortac, and then direct to the appropriate feeder fix for a north or south operation at Asheville, or direct to the airport if the weather permits visual approaches. The reason it's best to fly the airway to Kessel first is that it keeps the flight in airspace controlled by Washington Center and avoids airspace used for Dulles and Washington National arrivals and departures. This route is great on a pretty day, but as you look at it on a chart, it does go over rough terrain most of the way, and there are not a lot of close-by airports. The ones that are there are in valleys or, in the case of Ingalls, perched atop a ridge. It's only as you fly across the New River Valley that you find a proliferation of airports, but that condition quickly changes back to near airportless rough terrain. And finally, you fly over or near Mount Mitchell, which at 6,870 feet, that's including a tower, the mountain is actually 6,684, is the highest point east of the Rockies in the U.S. It's a beautiful route to fly on a nice day, but a prudent route survey would, on a bad day, suggest a route over Montebello, Roanoke, and Barrett's Mountain, where the minimum safe altitude is 3,000 feet lower, and there are more airports along the way. There's still some rough terrain, just not as much. Incidentally, when considering a route or when flying one, be aware that the FAA changed the name of a lot of vortacs a while back, including the word mountain, where there are mountains in the area. Hickory became Barrett's Mountain in North Carolina, for example. Just a little friendly warning that there's rough terrain out there. Weather has to be studied before flying. It is all important to the best altitude for your flight as well as the best route. Sporties has individual tapes on weather as well as a series on flying weather by seasons. Here I'll just suggest that before flying you get all available weather information, write it down if you get it over the phone, And if there's any question about the suitability of the weather for flying, take the most conservative action that comes to mind. At the airport, it comes time to pre-flight the airplane. There's a pre-flight checklist in the POH, though a lot of pilots follow the generally acceptable, thorough walk-around inspection of the airplane. Electronic checklists are also available. Whatever, don't fall into the kick the tires and light the fires syndrome. As airplanes get older, they require more thorough pilot inspections. I'll give you an example. In my POH, all it says to do is check the freedom of movement and the security of the control surfaces. I've learned, though, from a number of service bulletins issued on the tail to look for other things as well. Skin cracks on the horizontal stabilizer are common, especially on the side with the trim tab. I have a couple of patches on my tail. Corrosion on the elevator and the trim tab is also common, and obvious corrosion is not a good companion on a flight. Also, the trim tab actuator rod should be checked as in good shape with the nut on the bolt secured by a cotter pin. There have been some problems with the rivets that attach the skin to the ribs at the leading edge, so it's a good idea to give it a little squeeze to make sure everything is tight. Finally, the horizontal stabilizer attachment points have been known to crack, so it's good to give the tail a gentle tug to see if anything is apparently loose. People who watch me pre-flight my airplane think I have a preoccupation with the tail. It comes from knowledge of all those service bulletins Cessna has issued on this area. Most of the items mentioned apply to all airplanes, too. You might find it helpful to ask a technician if there are any particular items to look for on the airplane or airplanes that you fly. There's another item I always double-check. The baggage door may look closed, but the latch might not be latched. Airplanes will fly with the baggage door or doors open, but it's not polite to spread your dirty underwear over the landscape as you come back to land and close the door. When following the pre-flight checklist, give special care to the part about draining the sumps. If there's a lot of water in the tank, the sample might look sort of okay because there might not be a line between water and gas. It'd be all water. Give it a good sniff to make sure it's avgas. Water doesn't smell like much of anything, and jet fuel smells like kerosene, which it is. A piston engine won't run on water or kerosene, so make sure you get pure samples of that good-smelling avgas from every drain on the airplane. Back up the sniff by rubbing some of the fuel between your fingers. Jet fuel feels greasy, and water feels watery. Some drains aren't obvious, so know where all are located. My airplane, for example, has 7. It has become politically correct not to dispose of your avgas samples on the ground, but don't let the zealots who are trying to save the world from everything cause you to neglect this important part of the pre-flight. A lot of airplanes are lost every year because of fuel contamination, and crashes are much more harmful to the environment than a few ounces of well-spread avgas. One other thing, don't fail to pre-flight the airplane and drain the sumps after an en route stop. This is often neglected. The rules cover removing any ice, snow, or frost from the airplane. I read a report the other day of an accident where a pilot took off with so much ice on his airplane that it resulted in strange aerodynamic events that culminated in the ailerons fluttering and causing structural damage to the ailerons and the wings of the airplane. It was deposited in a field before it finished dismantling itself. If the airplane is put into a warm hangar to melt frozen stuff, be sure it's dry before it goes back outside where any water will just naturally refreeze. When you complete the pre-flight, go through a mental review of the super important items. If the fuel is uncontaminated and the fuel vents are okay, it will have fuel on which to run. If caps, fuel, and oil are secure, none of the stuff should siphon out. If the prop has no nicks or loose blades, that should be okay. If the static vents and pitot head are clear, the pressure instruments should work properly. When loading the airplane, do secure any items in the cabin that could hurt you or your passengers or damage anything were they to be thrown around in turbulence or in a less than gentle stop. We strap ourselves in for good reason, and the reason is just as good for baggage. A friend of mine used to carry a heavy tool chest in his Bonanza, unsecured, until he flew into the rough one day and the chest moved about the cabin and broke out a window. We used or followed a checklist for the pre-flight, and the same should be done once you settle into the pilot's seat and get ready to fly. A pilot who uses a printed or electronic checklist each and every time is less likely to leave a stone unturned. They are not for sissies or those with memory loss. If you run across a checklist item that is puzzling, ask someone who knows the airplane well why that item is there. On many Bonanzas, for example, the checklist specifies that the aux fuel pump be off for takeoff. Why? The engine will hardly run because the mixture is too rich with the pump turned on. Anyway, there have been a lot of serious accidents caused by pilots not using checklists or omitting items on checklists, and this is a risk you can minimize by using a checklist every time you fly. Some checklists don't seem in logical order, and as our airplanes get older, we tend to add equipment that might not be on the checklist. The solution to this might be preparation of your own checklist that results in a logical progression around the cockpit and instrument panel. I have redone mine where the next item to check is always right next to the last item checked. Just be absolutely sure if you do this that your new improved checklist includes each and every item on the manufacturer's list in addition to the things you add. I fumbled with checklists for over 40 years, looking for them in side pockets and seat backs and spilling stuff all over the floor when I'd retrieve the checklist. Then one day it dawned on me there's a better way. I now keep my checklists in the little Jepson book I make up for every trip with the charts for that trip in the book. And it's got my checklist, plus all the V-speeds for the airplane, plus all the basic weight information. Handy for every trip. One pre-flight item that isn't on most lists is the passenger briefing. Not only show them the belts and exits, tell them what the flight will be like for the first 15 or so minutes. Then explain that you'll be busy for a while after takeoff, but will answer any questions after the airplane is away from the airport and established in cruising flight. Before takeoff, the airport also needs a little pre-flight attention. If it is home base and the weather is good as well as calm, not much attention is required. If it is an unfamiliar airport, if the weather's bad, or if the wind is strong and perhaps crosswind, then some thought is required. For example, if there is a strong crosswind that appears 90 degrees to the runway, which is the best way to take off? A pre-flight inspection might show higher terrain upwind of the departure path in one direction. That would mean downdraft activity in the initial climb, and a smoother and better takeoff and initial climb might be possible in the other direction. Look at the windsock for a while, too, to get a feel for how the gusts are working. Generally, in the northern hemisphere, the wind will shift in a clockwise direction at the surface with an increase in speed. Sailors use that to good advantage in races. It is true over land, too, but any buildings or other obstructions upwind of the runway might make the wind do things other than what it might do when flowing over a smooth surface. That's why the windsock study is in order. This is true on big airports, too, where you might get the wind from the ATIS or the tower. With all the modern technology, they do still put windsocks out on the airport where we can look at them, and sometimes they tell a different tale than the information you might get from somewhere else. If the departure is from a minimum length runway and you use the conservative 2.2 times the ground roll to determine that the runway is long enough, establish where you think the halfway point is before you start your takeoff. This is where you should be when reaching liftoff speed. And if there's a serious airspeed shortcoming when you reach that point, there should be enough runway to stop if the takeoff is aborted. The rewards of thorough and competent pre-flight planning come when you taxi into position for takeoff without nagging questions and doubts. Everything has been considered, every procedure has been followed, and everything looks good. It doesn't take a lot of time, it reduces risks, and the rewards are great. That's quite a combination. In the next tape in this series, we're going to cover what comes next, the takeoff and initial climb. Thanks for flying with us, and fly safely.
Weather is one of the most important elements of pilot knowledge. Sporty's weather video series provide much more than just the basics. They're so real, the time you spend watching them should be loggable. There's one video for each season, and in each you'll come to understand the forces that combine to create the conditions distinctive to each season. You'll ride along in the cockpit for detailed explanations of the weather systems as you fly through them, noting the effect on the airplane, said to be the world's best weather sensor. You'll compare the actual weather to the weather synopsis and the weather briefing, and learn many valuable real-world lessons for dealing with the atmospheric culprits that can make a flight less than pleasant. Your host and guide on this meteorological odyssey is Richard Collins, noted aviation writer and author of such authoritative books as Flying the Weather Map and Mastering the Systems. You'll meet Mike Rosing, a commercial pilot who'll explain the systems, how they form, and how they affect your flying, whether you fly only during a particular season or year-round. The Sporty's Weather video series is a valuable addition to your aviation library. Call Sporty's